Hello. Going to kick things off. Just a very quick note for everyone on this session. This session was originally supposed to be a fireside chat, but as you can see, I'm here alone, so I'm not doing a fireside chat with anybody else. I figured, given the short notice, probably best to try and involve you fine folks and make this a fireside chat between me and you. So I will give a bit of an intro into my thoughts on why AI needs crypto. I'll give you a bit of an intro to myself and kind of why I care about this, and I'll probably do that for 5-10 minutes, and then hopefully hand it out to you guys. And I'm happy to answer any questions about AI, crypto, decentralization, why AI needs those things, and also what we're doing at Gensyn. And obviously I'll explain a little bit more about that. So yeah, I'll kick things off. I'll give you an intro to me, and then and why I think this is an important problem, and then hopefully hand it to you guys. If you do have questions, please, I think, come down to the front and they'll hand you a microphone, or just sort of put your hand up and wave, and I think someone will bring you a microphone, and then we can get you involved. We can make this a kind of interactive sort of fireside chat, ideally. So to kick things off, I'm Ben. I'm the co-founder of Gensyn. My background originally is in the machine learning space, so AI and machine learning, not the crypto space. I'm a bit of a recovering academic, so I started out doing a PhD in machine learning back in 2015 when deep learning was exploding for machine learning in general and for computer vision. I think, as we all know now, deep learning and deep neural networks are kind of very exciting. Most people will have interacted with them. Most people will have used ChatGPT and image generation models and things like that. But back in those days, it was kind of within the academic community. And one of the biggest things I realized whilst doing my PhD was the compute crisis that we were starting to be in then, and we're definitely seeing now. My research focused on evolving and growing the structure of deep neural networks, which is an incredibly computationally intensive task. Essentially, you're training and retraining candidate neural networks over and over and over again. I was doing this as a PhD student with 4 GPUs under my desk and a workstation I'd built myself, and Google was starting to do it with thousands of GPUs in a data center that they would run for weeks at a time. And what I realized doing that was that I was being significantly held back by reasons that, to me, weren't necessarily valid. They didn't need to be the case. The main things holding me back were access to capital and access to resources and assets, rather than knowledge or ability. And I realized if that was the case for me, it was the case for a lot of other people in the world, and it was generally holding back the machine learning space and human progress. So Gensyn now as a company solves that problem. We are a decentralized machine learning compute protocol. So we connect up all of the machine learning capable compute hardware in the world and provide that as a resource to anyone training machine learning models. When I say training, I mean essentially distilling value in data into model parameters or weights. And the current situation, the current way that you do that is to rent time on devices owned by a very small number of people. So AWS, Google Cloud, people like that, they buy up all of these chips and then they rent them out to people for exorbitant prices. Gensyn is creating a new infrastructure that sits in between the device owners, so the supply side, and the machine learning engineers, the demand side. And the idea is to be a protocol, almost in the Web 1 sense. It's a communication protocol that allows those two parties to interact. And it eliminates all of the centralized bottlenecks and the ways that the companies right now manage to maintain profit. And this kind of leads us on to why, I guess, the topic of this, which is why does AI need crypto? When I say crypto, I mean crypto, decentralization, Web3, kind of whatever we want to call it, blockchain, or the space that we all exist in. And I think there's 2 main reasons in my mind. The first reason is kind of backwards looking. It's looking at the market for machine learning and why people have a monopoly, why they can continue to create profit over the machine learning space. We're generally, as a society, okay with that if that company is bringing something new and novel to the market. What we don't like is rent seeking. And what we see in the machine learning space is lots of rent seeking on top of core resources. Compute is one of the most vital core resources in our minds, and a way to eliminate that rent-seeking behavior is to make a much clearer connection between the owners of the compute and the people who want to use the compute, and stop the cloud giants from being able to essentially sit on top of that compute and make money on it without really doing any additional work, because that's not competition working in the kind of sense it should. So that's the kind of backward-looking view. It also includes the kind of chip shortages that we hear a lot about. We're not making enough chips. It's very hard for us to make those chips. NVIDIA have a very strong hold on the AI market because they're able to do that. and the supply chain of chips themselves is just very difficult. So if you were to just graph the demand of machine learning hardware against the ability for humanity to create more machine learning hardware, those things are diverging very rapidly. Two ways you can address that. One is make more chips. The other is make the usage of the current chips more efficient. And that's what Gensyn focuses on. So that's the backward-looking view. That's looking at the market right now and saying, hey, with decentralization, can we change that? And we can. The forward-looking view is, how is the machine learning space going to change? What's going to be different in 5, 10 plus years? One of the things that we think is very important is that we need to make it so that models will be able to interact with the core resources themselves. Right now, everyone training a machine learning model is a person, and they're perfectly happy to go through various kind of like human layer aspects in order to do that. So they'll go through people, they'll use legal contracts to secure trust, they'll interact with businesses, they'll use infrastructure built by people, they'll interact with customer service agents, etc. In the future, we think models will be the ones building other models. For that to happen, all of those human aspects need to be automated away. We need to replace those things with technology, and that's what Gensyn's doing. One of the absolutely crucial things there is verification. We need to know that if I have sent a part of a machine learning model to a machine somewhere else in the world, that machine has actually done the training work that I expected it to do. Right now, we do that through lots of kind of human mechanisms. We do KYC, we have contracts, etc., and it's very, very slow, and it's a bottleneck. So if we replace that with technology, we can improve that situation, and we can make models much easier to develop, and we can let models build models. It leads to a very rich ecosystem of autonomous agents, all interacting, all building models themselves, and this essentially embedding space that covers the entire world and all of the compute in the world. I've been speaking for a while now. I'm happy to continue monologuing to you folks, but if you have any questions, I'm also very, very happy to answer those questions. So put your hand up, come down to the front if you want to ask a question. Otherwise, I will just continue telling you my views on machine learning and decentralization. But yeah, please, would love to open this up a little bit.
So one question that I wanted to ask is that there are a few solutions that enable people to rent out their compute that they have, for example, like 4090s, or if you have like V100s or A100s lying around from the used market, for individuals like VastAI, or, VastAI would be a good example of this solution. How's your protocol going to improve on that? And specifically, another item that I was looking into is that the network requirement for individuals is kind of strict because, AI is very bandwidth constrained, and high networking speed is something that AWS has on a pinch, and a lot of consumers and a lot of, small owners of compute don't really have, because, your internet provider is not necessarily going to provide you with gigabit speeds on demand, and that's going to be difficult for us. So how would you go around these two challenges, basically, improve on existing solutions and solve the networking issue?
Yeah, two great questions. So I guess to paraphrase, the first one is, how would what we're describing be different from the current centralized aggregators, essentially, where VastAI will allow anyone to list a GPU on their network, and then somebody else can use that, in comparison to a centralized provider where AWS has all the GPUs. So it's kind of an open network. So first question is that. Second question, how do you overcome the latency and bandwidth constraints of a truly open network where maybe you've got 3090s in people's homes running? That's obviously very different from AWS's big InfiniBand cluster of H100s. So on the first question, I think the VastAI approach is a solution to the backwards-looking half of what I described as being the problem. So you look at the market right now and you say, I have to go to a centralized provider, they have a stranglehold on the market, and they're able to make enormous profit off me. If we can unlock some latent supply, we can reduce those prices because we can bring supply into the market. I think the centralized approach like VastAI is a good approach. It's an improvement on what we currently have, but it's still bottlenecked. The way that VastAI ensures trust is via centralized KYC, essentially. So they have to onboard every person who brings a GPU to their platform, and they have to essentially ensure the user of the platform against malicious behavior from those supply-side participants. That sort of works right now, but it doesn't scale, because at some point that KYC burden overcomes the benefit of growing that network, and you hit a ceiling. And we saw this back in 2014. There was a company called VectorDash that came out of Y Combinator. They had this exact same approach, and they ended up pivoting into the cloud gaming space because they realized that overhead of centralized KYC and ensuring trust is just too high. That's why decentralization and blockchain is so interesting, because it allows us to solve that with technology rather than with people. So we can ensure that trust via a chain itself. It's easy to say, it's hard to do. In reality, you have to terminate disputes over very massive machine learning kind of non-deterministic tasks onto a chain consensus mechanism, which is incredibly difficult. But if you can do that, you've replaced those people portions with technology and you've made it instantaneous. So that's why you need decentralization on top of something like VAST to scale. VAST as well, if you did just a completely decentralized but kind of token-based alternative to VAST, you would still only solve that portion of the problem. You need the verification and you need the kind of programmatic transactions to scale to the second portion of what I said earlier, which is machines interacting with machines. It's machines triggering that training and able to use this infrastructure without a human ever involved. In that case, they need wallets, they need tokens, they need access to the other core resources like data and expert knowledge and things like that. And we need all of those portions before we can unlock the true new machine learning future. So VAST kind of improve what we currently have. We view them as like a 10 to 20% improvement on what we currently have. With Gensyn, we view as building the next kind of step change. The idea is change the way machine learning is done completely. That leads into your second question, which was the latency bandwidth constraints. And if you look at the way that machine learning development has developed and progressed over the past 5 to 10 years, we've gone down this path of highly centralized models getting bigger and bigger and proving to the world that we can do very interesting things. So we view that as the tip of the spear for research. So the first thing that we do is say, hey, world, look, we can build models that are incredible like this. The way that we've done it is super fragile, and it requires us to put loads of GPUs in a data center together and make them like really fast interconnected, but it works. That's the first step. After that, we go back to kind of general computing principles. We look at distributed systems and we say, how do we actually scale this properly? And what Gensyn thinks is that scalability will be highly distributed, highly decentralized. It won't be adding another 1,000 GPUs into a data center. It will be removing that kind of that small step change and saying, what if you can access 1 million MacBooks now? Could you build a model differently over those devices? And I think one of the things that's interesting is the machine learning space has a really short memory. People will look at the progression of these models and they'll think, oh, this is the only way to do this. But actually, if you look back, we've only been doing these hyper-centralized models for a few years. It was a really interesting way of doing it, but there are plenty of other interesting ways to do it. So there's a kind of chicken and egg problem here, and there's a naivety that can come if you're building something like us, where you say, hey, we'll just build this massive network of all the devices in the world, and then people will just turn up and build like crazy decentralized models over it. That's true to some extent, but we also have to prove it. So we're doing research to say, rather than building a hyper-connected model that's fragile and if any piece kind of falls, the whole thing fails, let's build a massive model where it's lots of different pieces all interoperating, and replication between those pieces allows us to drop out pieces and bring in other pieces, combine different modalities, and generally make this huge kind of rich, sharded embedding space over the entire planet's compute resources. We think that's the true kind of future of AI, rather than these fragile centralized models that we're sort of focusing on as society right now. That view of AGI as being like one model in OpenAI's data center, we think is just flawed. It's a very short-term view. The future is rich bits of models everywhere on everyone here's phone, and then if you're running something through those models, you're going to connect up all the different pieces as and when you need to get the answer that you need.
Hey, I was wondering how you would ensure the privacy, like I send someone my model and then perhaps someone steals it and now there are like disputes and stuff like that.
Great question. Another tricky one. So that's something that we care about a lot. As a brief aside, my previous startup was actually in the privacy space. So I was building individual consumer privacy tooling. I think in the future we will have a lot more control and agency over our own data. I think we've gone down a path particularly with social media, where we've become accustomed to giving up a lot of our data in exchange for services, but not in a kind of granular consent-based way. And I think we do need to move back to that. I think it's slowly happening. What I learned from my previous startup is that a startup's probably not going to do it. It's going to have to come from one of the big kind of giants who already have a lot of us as users. Apple are doing pretty good work on this. They've got it as a brand value and they're doing really good research. So it's starting to happen. But when it comes to our infrastructure and the decentralization of AI, what we found when we talked to potential users of this system is that actually a lot of machine learning work is happening in the open. We're seeing a lot of open source models being developed. They're being developed on open source data. Compute as a barrier is actually much larger than the access to data and access to model architectures. So a lot of people are using open versions of those two things, but still can't access compute. So what we found is 50% of those people are happy to use completely open compute where everyone can see what they're doing just because they're unable to do that right now and they want to be able to build these models. After that 50%, the remaining 50% are split into two. So all of them care about data privacy, like the individual training data going into models, and half of them care about model privacy, which is the weights or architecture of the models themselves, the kind of proprietary design of the model. That gives us a roadmap to say we can develop in the open. We can build the primitives, the verification, the hard things, the bandwidth and latency kind of research to overcome those constraints on completely open models at first, and then we can move to data. After that, we move to models. And the roadmap that we have on the technical side reflects that. So right now, building in the open, obviously you don't need extra technology. To build on top of private data, there are various techniques that are coming to fruition. So you can do things like differential privacy. It's very tricky, but it allows you to essentially anonymize data that goes into models, so you can take out the kind of individual aspects and use the value in the data without identifying people. It's subject to attacks, and there's lots of reasons why it's hard to implement, but it's possible. Another one is functional encryption, where there's a really interesting technique you can do with a neural network where you replace the first layer of the network with a functional encryption key. And that key then decrypts the data, but only for the operations of the network. So it's homomorphic over the rest of the execution of the network. Very long story short, that lets you train on ciphertext. So you can encrypt your data with an unencrypted model. You can send that encrypted data to a party who has the model and the compute power. They can train the model on that data, and they can send the model back, and they've never seen the data. They have no way of decrypting it. So that solves the data privacy problem. It also comes with downsides. You then have a model that every time you want to run data through it, you have to encrypt it first, which is a bit annoying, and you kind of lose a little bit of information in the data, but it works. The final piece is the model privacy piece, and that's where fully homomorphic encryption comes in. Fully homomorphic encryption is very early as a technology. It's possible for model inference right now. It's very, very slow, and it's incredibly slow for training. So from our perspective, it's maybe 5 years out before we'll get that really realistically applied to training, but it gives us a solution and it gives us a roadmap to work towards. So there's some pretty exciting techniques in summary, and there's also, we have a roadmap for what the users actually want. And surprisingly, half of the users in the early cases just want to build open source models on open source data, but at the moment they can't get compute.
I guess it's going to be me again. One of the problems that I saw in the space is that the fact that the compute comes in many different forms and it's not uniform, and that specifically plays very strongly into NVIDIA's hands. Basically, right now, if you look at this space, that there are kind of 2 points, in terms of the training data, and that kind of gets all the other vendors of compute out of the game. So basically right now, if you want to get state-of-the-art with, say, good FP8 or Int8 capabilities, you look for H100. And if you're looking for a more cost-sensitive, especially on the supplier side, that's probably going to be like 2 generations back. V100 would be the best choice for you. However, there are like a lot of solutions by AMD, by Intel. They are coming up with their Gaudi line. And the question here is that how do you ensure that in this case you get, if most people are optimizing for NVIDIA, how do you make sure that people having compute from other vendors, say Apple is completely up tap right now, and they have pretty good machine learning capabilities. How do you make sure that those people get, a fair return on their compute? Because in that case, if you have like a lot of AI models optimized for NVIDIA, they disproportionately reward NVIDIA's hardware in terms of performance. As a result, if you have AMD, you're struggling to get good returns on your, because the model just does not run well enough with AMD hardware, for example.
Yeah, another great question. I think one of the issues here is NVIDIA's ability to capture the market with CUDA, so the software side of the market. And I'm going to have to be very quick here because I only have a few seconds left. But in essence, that's down to the protocol design. So we're building the software layer that allows that to happen. Our long-term goal, and I think this is probably why we differ from the networks that you see that are only addressing half of the two things that I mentioned at the beginning. They're only addressing the current situation, so the way that models are currently built and the way the market currently works, and they're not looking forward to the way the market is going to work in the future. If you're looking forward, I think we need to focus on commoditization of compute. If you look at most machine learning engineers who are after hardware, they think they need the H100s, the H200s, the most powerful devices that they can get from NVIDIA. But in reality, the tasks that they're doing don't need those pieces of hardware. They could work over AMD hardware, they could work over Intel hardware, they could work over some of the custom chips, but the software layer doesn't exist. And so the proper protocol design involves solving the trust problems, but also solving those software problems. And I think that's one of the things that's really difficult. And one of the big problems is it takes a long time and it's very expensive to do because NVIDIA has been very careful to capture that stack with CUDA. You essentially have to disrupt CUDA and you have to build around it so that you can bring in the other devices. It's something we're focusing on very heavily. We're building an entire stack to do reproducible machine learning over heterogeneous devices. And the idea of that is it allows machine learning engineers to stop thinking about which device they're using and just think about the fact that they need to distill value in data into models, and that's it. They should only have to think about that. It's a little bit similar to the serverless shift within tech in general, where Heroku allowed people to not think about that. I'm being told to wrap up, so I will wrap up there, but please ask me any questions. I'll hang around for a while and happy to talk more. Thank you.